Bismillah ar-Rahman ar-Rahim. Alhamdulillah wa salatu wassalam ala Rasulillah. This is going to be the last video or lecture in chapter 4. Okay. Before we close this chapter 4, we need to learn about a new topic. We're going to talk about it briefly, which is the block diagram. What do we mean by block diagram? Okay, we're going to need the block diagram in chapter 10 when we reach control systems. So we're going to talk about block diagrams when we reach control systems in chapter 10, inshallah. Okay, for now, what is a block diagram? This is a block diagram. A block diagram is a graphical representation of the transfer function. Graphical representation of the transfer function. So what you see inside the block is the transfer function. Okay, what you see into the block, your input. What you see out of the block, your output. Okay, so two things you need to remember when you look at the block diagram. Always, there are two things you need to remember. It's always in the Laplace domain. Always in the Laplace domain. Okay, it's not in the time domain, it's in the Laplace domain. Also, this signal always, the output always will be the transfer function multiplied by the input. Okay, so the output here, whatever the signal, the out signal, will be equal to this transfer function multiplied by the input. Multiplied by the input. Okay, this is what you need to remember. Okay, all right. What you see here, this is a typical control system. This is a block diagram of a typical control system. This is what we call reference input. This is the output. This is the feed forward transfer function. This is the feedback. This is summing point, plus, negative. This signal is the error. We call it the error because it's the difference between what I want, the input, minus what I get, the output. That's why we call it error. We're going to talk about this more in detail, inshallah, when we come to chapter 10, inshallah, control systems. Okay. For now, all you need to know, what's a block diagram? What does it mean? Okay. What is this signal? This is the input. What is this signal? This is the output. What's inside this block? This is the transfer function. Okay. So according to Laplace transformation, or the definition of a block diagram, if you have two blocks in series, the equivalent will be the multiplication. Okay, because this signal is equal to this transfer function multiplied by this signal multiplied by this. So the equivalent of this is the multiplication. Okay, this is what you need to remember. And you need to know what is this summing point, the meaning of summing point. So if you have a transfer function into the summing point plus another transfer function into the summing point, the equivalent of this will be the addition of the two transfer function. Okay, we will talk about it later more in detail. Okay. For now, this is all what you need to know. What does this mean? This is a block diagram. This is the input. This is the output. This is the feedback. This is the error signal. Okay. We're going to talk more about this, inshallah, in chapter 10 when we come to control systems. Okay. So you need to make sure to keep in your mind that everything in this block diagram can be represented as a algebraic equations, linear. Okay, we will talk about this. I will leave this, inshallah, to chapter 10 when we come to chapter 10. For now, I will give you an example. This is a problem that we solved earlier in the last video. Okay, what I want here, I want to this is the transfer function of the system. Okay, draw the block diagram of the system. So this is the transfer function in between. So when you want to draw the block diagram, you need to know what's the input, what's the output. So in this problem, he said this is the input. This is the input, he said, right? And here he said this is the output. So we derived this equation last time, right? So it's going to be here. This is the transfer function, k over bs plus k. So what's the input here? The input is x. In the s domain, it's going to be x of s. And here the output y. In the s domain, it will be y of s. And this is the block diagram. That's all. This is what we need to learn at this point. Okay? All right. There is another example. Yeah, one more thing I would like to tell you. You see this problem? Do you remember this problem? This is a mass with the single degree freedom system, X. There's some problem with the pen. Okay, this is a spring. And we have a damper. External force, F of t. F of t. Okay. Well, let me redraw this again. I don't know what's the problem with the PowerPoint. Okay, it's becoming showing random lines. Maybe a bug in the... Okay, let me redraw it here. This is the problem here again. Okay, this one is like we have a mass. Okay, see, this is the error I'm talking about. X. Okay, this is K. This is C. He called it C, right? Not B, okay. K, C. And we have external force, F of t. Okay. And here the input is F of t. Output is x of t. What's the transfer function? We did it last time. The transfer function will be what? The transfer function will be 1 over ms squared plus cs plus k. We did this last time, if you recall. Okay. Draw the draw the block diagram. Can you draw the block diagram? Yes, we can. Let me put a new slide. So this is the block. 1 over the transfer function ms squared plus cs plus k. The output is what? X of s, and the input is the external force F of s. So this is my block diagram. Okay. This is one way to draw the block diagram. The idea of this example, just to show you that there are many ways to draw the block diagram. There are many ways, not just one way, many ways. Many ways. So what did he do here? He started with the equation of motion after taking Laplace transform. Okay, and then he said the output is x, and here x. So the first loop, it will be 1 over, the feed forward will be 1 over ms squared. Okay, and the second loop, it's going to be, where is it? K minus K, see, minus K. Third loop, okay. How can you reduce this? You can reduce this using the idea of this identity from algebra. You start from this signal, the error. This is the error signal. What's the output here? The output is what here? This one, G, equal to what? Equal to this signal. Okay. So here the output is C. C output equal to this transfer function multiplied by this signal, R minus CH. Okay. From here you can derive a transfer function relating C to R directly without this loop. So from this loop, the equivalent will be, if you manipulate, if you derive this equation, it will be G over 1 plus GH. How? From this equation. You collect all the coefficient of C together on one side, You collect all the coefficient of R together on the other side, and then you will get the transfer function 1 plus GH. You don't have to prove it, okay? This is already proven, okay? All you have to remember is this. This is what we call the equivalent block diagram for any loop. Any loop can be reduced into a single block like this one. It will be G over 1 plus GH. What is G? G, the feed forward, the transfer function on the top. What is H? H is the feedback transfer function in the bottom. So the equivalent of this loop will be G over 1 plus GH. So everything in here can be represented in single block with the same input and the same output. So this equivalent to all this loop. Okay. Same thing here you can prove. You can find the equivalent of this the equivalent block diagram, or the equivalent block, sorry. Okay. Or block equivalent block diagram, okay? It will give you a transfer function. Then you find the equivalent a block for the outer loop. The equivalent of the outer loop will be what, ya shabab? What do you think the equivalent block? It will be this transfer function. This one, which is here. Same. You don't have to prove it for now. I'm not gonna ask about this in the next quiz or the midterm. This is important when we reach control systems, inshallah. Okay. At this stage, again, ya shabab, the conclusion. At this stage, we need just to understand what do I mean by a block diagram. A block diagram is a transfer function, a graphical representation of your transfer function. What's inside the block? Transfer function. What's into the block? This signal. This is the input. What is out of the block? The output. How much is this output? It's equal to the block transfer function multiplied by the input. This is the conclusion of today's lecture, inshallah. This is what you need to learn for the next quiz and for the midterm, inshallah. Okay. The rest about the control systems, we will talk about it, inshallah, later when we reach control systems, okay, in more details. All right. Thank you very much.